Hey there. So you have decided to enable R8. Are you feeling a bit confused or even frustrated? We have all encountered challenges while adopting R8. The mysterious crashes that only appear in your release build, unreadable stack traces, and debugging sessions that run longer than expected. Or maybe you have already found yourself in that cycle of adding just one more keep rule, attempting to fix that mysterious crash. Today, you'll learn how to debug and troubleshoot R8. I'll show you powerful tools, share best practices on diagnosing issues, and how to fix them. When you enable the R8 optimizer, R8 streamlines your app by removing unused code and resources, rewriting code to optimize runtime performance, and more. Check out the Adopting R8 video on Performance Spotlight V to learn more about this. When optimizing, R8 statically analyzes your app and creates a call graph for all the contained code. Code that appears unused will be removed. A common false positive is caused by the use of reflection APIs. And that's where keep rules come in. Keep rules explicitly instruct R8 to preserve the parts of your code that are used with an indirection, making sure they are not removed. This keeps your app working as intended. In the app's build file, we can define the files that provide keep rules to R8. The Android build tools provide a file with important defaults that you should apply right away. To add your own keep rules, create a new file and add its name as well. Now you can start configuring keep rules in that file. There are many ways to write keep rules. Let me show you the basic syntax to add them. A keep rule starts with a hyphen, followed by a keep option, which is the main command. The keep option defines the scope of what to retain. The keep command tells R8 to preserve both the class and its members. While these commands work by themselves, you can add one or more comma-separated modifiers. Next is a class specification. This defines the scope that the rule applies to. You can start with the keyword class, followed by the fully qualified class name. That means you need to include its package name. You can become more specific and tell the optimizer exactly which members to keep within that class. This looks oddly familiar, almost like a regular class declaration. Within the declaration, list members and methods you want to keep. For more information about how to write keep rules, check out our newly updated developer guidance. You can find a link in this video's description. Keep rules are at the core of R8 configuration. So let's take a moment to talk about best practices and common pitfalls. There are global keep rule options that lets you turn off certain aspects of app optimization. Be mindful about these keep rules, as these affect optimization in multiple classes and thereby limit the benefits that come with a performant app. The most important global keep rule to avoid is don't optimize. Using it effectively disables any optimization that R8 can provide for your app. It prevents code optimization like dead code elimination and method inlining. Adding this rule in a release build will result in a significantly larger and slower app for your users, drastically limiting the optimizations. You should never use this rule in production. Another dangerous global keep rule is don't shrink. When you add this to your configuration, you are telling R8 to stop removing unused code and resources. Adding the don't shrink keep rule means you are shipping a bloated app, forcing your users to download a much larger app. Finally, there is the don't obfuscate rule. When you use this, you are telling the build tool to skip the renaming process. Behind the obfuscation flag is the key minification step where R8 renames your human readable classes, methods, and fields into shorter names, saving a huge amount of space, especially in larger apps. While you might use don't obfuscate during debugging to keep stack traces readable, you should always minify your production build. Make sure to minify your app, or you risk missing out on significant performance, memory, size reductions, and shipping a larger app than necessary. Also, when writing specific keep rules, there's a common pitfall you need to avoid: using the inversion operator, the exclamation mark. The problem is, this rule does not mean keep the classes that are outside of this package. It means keep every single class in the entire application that are not in the specified package. This one line will match and keep all of your app's code and the code brought in from any other dependency that you have included. Because they are all matched as not being part of the declared package, this rule forces the optimizer to keep them all, which in turn prevents them from being optimized, shrunk, or obfuscated. You have effectively undone all your optimization with a single misunderstood line. The takeaway is to always write rules for what you do want to keep and avoid using the inversion operator wherever possible. Another common pitfall is using broad package-wide keep rules in the form of wildcards. A rule like this one will keep every single class, any fields and methods inside that entire package. This prevents R8 from doing its job for all affected code. It can't shrink classes or methods within that package, it can't optimize the internal logic, and it can't minify any of the names. With Android Studio Otter feature drop, we have added inspections, which will tell you when a keep rule is preventing R8 optimizations for a significant number of classes, just like this one. This is a sign that we need to define a more specific rule. Speaking of best practices, you should scope keep rules as narrow as possible so that R8 can have the highest impact on your codebase. One way to achieve this is to target a common characteristic, like keeping classes that implement a common interface. In case you have a common base class for the classes you want to keep, you could write a keep rule to retain only those classes using implements class specification. Another way to write specific keep rule is to use an annotation and write a keep rule that targets classes or members marked with it. With all the keep rules, you should also be specific about what members you keep to get the maximum optimization. In the cases where you find yourself adding a broad keep rule, you need to investigate exactly what's causing the issues with R8 and write a narrower, more specific rule. For a deeper dive, check out the guidance on keep rule best practices. A key pain point for developers when using R8 are stack traces of minified builds. In this demo, I have enabled the R8 optimizer in a modified version of the Androidify app. The app crashes on launch. This is a common experience when first enabling the R8 optimizer. Now that I am looking at Logcat, all I can read from the stack trace is a class not found exception. The rest of this stack trace does not tell me anything that I can work with. I cannot see which class contains the error, and I am unable to click into the relevant code section. This is because R8 has obfuscated our code. While this is a critical step for release builds, it creates a significant barrier to debugging. We just made it easier for you to debug this, right from Android Studio. And it's available for all projects starting from AGP version 9.0. This feature automatically de-obfuscates stack traces for you by reading the local mapping file and applying it directly within Logcat. Here is the same stack trace, but now it's completely readable. Automated Logcat retracing makes it easy to debug stack traces of minified builds. Now that we know where the issue comes from, let's dive in. We can see that the crash is originating from a background work class, which is called from Androidify's main activity onCreate method. In here, we are calling the task runner with a class name that is implementing the startup task class. The task runner is using reflection to dynamically call the method in the startup task class. After enabling R8, the pre-cached task was removed from the app because it is not accessed with a hard reference, but only indirectly. To resolve this, we need a keep rule. While you could write a rule specifically for the pre-cached task, a better, more maintainable approach is to keep any class that implements the startup task. This will cover pre-cached task and any other implementing classes at the same time. Let's run and see if the app works. And it's working. If you are debugging, R8 generates useful metadata during every build. The configuration file, which is part of the metadata, can be particularly useful. It contains all the keep rules that are applied to the app, both from the app itself and from any included dependency. You can find the configuration file inside the project's build output folder. This file can be used to spot any wild keep rules that prevent optimization and then remove the problematic rules from the source keep rule file. The configuration file is also useful to verify that a specific library's required keep rules were correctly applied into the final build. If you see code that you expected to be removed, use the "Why are you keeping" configuration option. It lets you know exactly why a piece of code was kept. When using this option, R8 outputs a path from the kept code to one of your app's entry points. We have more tips and tricks on testing and troubleshooting in our guidance. Check them out in the link mentioned in the description. All Android apps rely on dependencies. Many of these dependencies bring in their own keep rules. As a library developer, you can define internal keep rules, and you can also provide keep rules to the consumers of your library. This makes it easier to integrate the library within an app. As an app developer, make sure to pick libraries that work well with optimization. This could mean choosing code generation over reflection wherever possible. With code generation, the optimizer can more easily determine what code is actually used at runtime and what can be removed. For more information about code gen versus reflection and how to choose libraries, check out our developer guidance. Now that you have learned how to confidently debug your R8 enabled builds and use the tools available to troubleshoot your configuration, it is a perfect time to bring this into practice. All through this Spotlight week, we are monitoring the video comments and the social tag. Now, it's your time to enable R8. All the links from this video can be found in the description. Subscribe to the Android Developers channel for more in-depth videos and stay tuned for more content in this Performance Spotlight week. Thank you for your time.